In the quiet theatre of your own mind, imagine a simple machine. It consists of a single chair, a quantum device, and a button. The device is aimed squarely at your head. It is a weapon, but one governed by the universe's strangest laws. Each time you press the button, the device measures a quantum property, perhaps the spin of an electron, which can be up or down. The outcome is a perfect 50-50 chance, a true coin flip of reality. If the electron is measured as spin up, the weapon does nothing. You hear a faint click and silence follows. If the electron is measured as spin down, the weapon fires. Instantly and without pain, your existence is terminated. You press the button. A click. You are still here. You gather your courage and press it again. Another click. You are alive. A third time. A fourth. A 10th. 100 times you press the button. 1,000 times. Each press is a roll of the dice with oblivion. And yet, against all conceivable odds, you survive every single time. You are a statistical miracle of impossible proportions. From your perspective, the machine appears to be broken. But the machine is not broken. It is functioning perfectly according to the laws of quantum mechanics. And in this unnerving thought experiment, you have just confronted the most bizarre, unsettling, and profound idea in all of science. A concept known as quantum immortality. To understand this audacious proposition, we must first journey backward. We must travel to a time when the cosmos was thought to be a simpler place, a grand, predictable machine like an ornate celestial clockwork. This was the universe of Isaac Newton, a reality of absolute certainty. If you knew the position and momentum of every particle, you could predict the future. Imagine a billiard table of cosmic scale. The balls are planets, stars, and galaxies. The cue is the Big Bang, striking them all into motion. In Newton's world, every collision, every cannon, every fall of an apple was preordained, governed by immutable, elegant laws. There was no room for chance, no space for ambiguity. The universe was a story already written, and we were simply turning the pages. This deterministic vision reigned for centuries, offering a sense of order and reason. It was a comforting thought that reality was fundamentally knowable. But at the turn of the 20th century, this clockwork cosmos began to crack. Physicists peering into the subatomic realm found not a world of certainty, but a realm of phantoms, a domain of pure, untamed probability. They discovered that the fundamental constituents of our world did not possess definite properties until they were observed. An electron was not a tiny solid ball spinning in a specific direction. Instead, it existed in a hazy cloud of potential, a superposition of all possible states at once. It was simultaneously spinning up and spinning down. It was here and also there. Only the act of measurement, of looking, forced nature to choose. The moment we observed it, this cloud of possibilities collapsed into a single concrete reality. This is the central mystery of quantum mechanics. The famous double-slit experiment lays this enigma bare. Imagine firing tiny pellets like grains of sand at a wall with two vertical openings. Some pellets go through the left, slit some through the right. On a screen behind you, would expect to see two distinct bands marking where they landed. This is how our classical intuition expects the world to behave. But when physicists performed this experiment with single electrons, something utterly confounding occurred. The electron, a single particle, behaved as if it were a wave. It seemed to pass through both slits simultaneously. On the screen behind it didn't create two simple bands. It produced an interference pattern, a series of alternating light and dark stripes. This is the signature of waves intersecting, cancelling each other out in some places and reinforcing each other in others. It was as if a single ripple in a pond had passed through both openings at once. The truly baffling part came when scientists tried to watch. They placed a detector at the slits to see which path the electron actually took. The moment they did this, the moment they observed its journey, the wave-like behavior vanished. The interference pattern disappeared, replaced by the two simple bands. It was as if the universe knew it was being watched. The very act of measurement seemed to force the electron to abandon its ghostly superposition. It was compelled to behave like a respectable particle to pick a single path. This observer effect remains one of the deepest puzzles in physics. What is it about observation that forces reality to take a stand? The Austrian physicist Erwin Schrödinger deeply troubled by this, devised a thought experiment to illustrate its absurdity. He imagined a cat locked in a steel box, its fate tied to a quantum event. Alongside the feline is a radioactive atom, a Geiger counter, a hammer, and a vial of poison. If the atom decays a random quantum process, the counter detects it. This detection triggers the hammer, which shatters the vial, releasing the poison. The cat, according to the rules of quantum mechanics, is in a superposition. The atom is both decayed and not decayed. Therefore, the hammer is both fallen and not fallen. And the cat, until the moment we open the box and look, is both alive and dead. It exists in a macabre blend of life and death, a quantum ghost. For decades, the dominant explanation for this puzzle was the Copenhagen interpretation. Championed by Niels Bohr, it stated that the act of observation causes the wave of possibilities, the superposition, to collapse. Out of all the potential realities, our measurement selects just one. In this view, the cat becomes either alive or dead only when we open the box. Our consciousness, in a sense, crystallizes the universe. This idea, while functional for making predictions, left many physicists deeply unsatisfied. It seemed to grant a special, almost mystical role to the observer. It felt arbitrary, as if nature was hiding its true workings behind a mathematical curtain. Then, in the 1950 seconds, a brilliant and iconoclastic graduate student at Princeton proposed an idea so radical, so audacious, that it was initially dismissed as science fiction. His name was Hugh Everett III. He looked at the mathematics of quantum theory, the Schrödinger equation, and saw that it described a universe constantly evolving, constantly branching. Nowhere in the pure mathematics was there a collapse. Everett asked a simple yet world-shattering question. What if the collapse never happens? What if, instead of one reality being chosen, all times possible outcomes actually occur? This was the birth of the many worlds. Interpretation. To visualize Everett's proposition, imagine reality not as a single line, but as a vast, endlessly branching river of time. Every time a quantum event with multiple possible outcomes occurs, the river splits into multiple parallel streams. Each stream is a complete, self-contained universe. When Schrödinger's box is closed, the universe splits in two. In one branch of reality, the atom decays and the cat dies. In the other branch, the atom does not decay, and the cat lives. The crucial point is that the observer, the scientist opening the box, also splits along with the universe. One version of the scientist opens the box and finds a deceased feline. Another version of that same scientist, in a separate parallel cosmos, opens the box and is relieved to find the cat alive and well. These two versions of reality are now forever distinct. They can never interact or communicate with each other. Each inhabitant of each branch believes their reality is the only one. They are utterly oblivious to the infinite copies of themselves living out every other possible permutation of existence. This is a staggering vision of the cosmos, a reality where every choice, every chance event, every quantum fluctuation spawns a new universe, creating a near-infinite, ever-growing multiverse. It suggests that somewhere in another branch of space-time you chose a different career. Somewhere else you married your childhood sweetheart. In yet another, the dinosaurs were never wiped out. Every possibility, no matter how remote, is played out in some corner of this grand cosmic tree. Hugh Everett's theory was met with ridicule and disbelief. The scientific establishment, particularly the influential Niels Bohr, rejected it outright. It seemed too extravagant, too wasteful of worlds. Discouraged, Everett left the world of theoretical physics behind. He went on to work in military analysis and commercial computing, but his idea of this many worlds concept refused to die. It was kept alive by a handful of physicists, like Bryce DeWitt, who saw its profound elegance and logical consistency. It solved the measurement problem without invoking a mysterious collapse. It took the mathematics of quantum mechanics at its word. And it is from this extraordinary branching view of reality that the strangest idea of all quantum immortality emerges. Let us return to our chair, our button, and our quantum weapon. You are about to press the button for the first time. The electron is in a superposition of spin up and spin down. The moment you press the button, the universe splits. In the spin down branch, the gun fires. Your life in that universe comes to an immediate, definitive end. The consciousness, the stream of awareness that is you in that branch ceases. There is nothing more for it to experience. But in the spin-up branch, the gun clicks harmlessly. You in times that time's universe are still alive. You are still conscious, still able to think, to feel, to press the button again. From your subjective viewpoint, you have survived. You can't experience the universe where you died because, well, you're dead there. So, you press the button a second time. Again, the cosmos bifurcates. One new timeline is created where you are terminated, another new timeline is created where you survive. And again, your consciousness, your personal thread of experience can only follow the path of survival. This is the core of the quantum suicide thought experiment. No matter how many times the button is pressed, your awareness will always, by definition, find itself in a branch where you lived. The universes in which you die will branch off and continue without you. But from your perspective, you will witness an impossible series of miracles. The gun will click 1,000 times, 1,000,000 times. The odds against this are astronomical, a 1 followed by hundreds of thousands of zeros. Yet, for the conscious observer in the chair, it is the only possible outcome they can experience. You are not truly immortal in a classical sense. Countless versions of you are perishing in other timelines, but your subjective awareness is shunted again and again into the reality branch where survival occurs. You become a kind of reality surfer, riding the wave of existence through the one sliver of the multiverse that allows for your continuation. This concept extends beyond a contrived thought experiment. Imagine crossing a busy street without looking. In a vast number of universes, you are struck by a car and killed. But in a tiny fraction of them, a driver swerves at the last second. A bird distracts you, making you hesitate. A shoelace comes untied, causing you to stop. Your consciousness will always find itself in one of these lucky timelines. To the outside world, you would seem unbelievably preternaturally fortunate. You would walk away from plane crashes, survive terminal illnesses, and dodge bullets with the luck of a cinematic hero, but you would feel none of it. Your experience would be seamless. You would simply be the person to whom these things happened, the person who, against all odds, just keeps on living. This leads to a profound and deeply unsettling philosophical abyss. If this interpretation is correct, what does it mean for our identity? Which of these infinite versions is the real you? Are you merely the sum total of all your branching selves? Or is your consciousness a single precious thread winding its way through the labyrinthine corridors of the multiverse? The implications are staggering and in many ways terrifying. Quantum immortality does not protect you from pain, from grief, or from decay. In some branching realities, you might survive a terrible accident but be left permanently disabled in chronic agony. Your consciousness would be forced to inhabit that timeline of suffering because the alternative was non-existence. It guarantees survival, but not the quality of that survival. More chillingly, you would be condemned to watch everyone you love grow old and die. Your friends, your family, your partners, they are not the subject of the experiment. Their lives are not protected by this strange loophole of consciousness. You would become a permanent fixture, an eternal witness to the endless cycle of birth and death around you. A lonely traveller through the eons, carrying the ghosts of all the loved ones you have outlived across countless branching worlds. The solitude would be unimaginable. And what is the end game for such a being? Quantum immortality doesn't prevent aging. Your body would still wither, your mind would still degrade. The process of death by old age is not a binary on or off event like a quantum gun. It is a slow, gradual decline of 1 billion interconnected systems. Perhaps your consciousness would be forced into ever more tenuous states of survival, finding itself in branches where freak biological events keep a failing body barely functioning. A mind trapped in an eternal twilight of decay, unable to fully pass away because there is always some minuscule probability of another heartbeat, another breath. This is not the triumphant immortality of myth and legend. It is a potential cosmic horror story, an existence stretched to the breaking point and then far, far beyond it. And what of the universe itself? Even it is not eternal. The cosmos is winding down, destined for an eventual heat death. A time trillions upon trillions of years from now, when all the stars have burned out, when all matter has decayed into a thin, cold soup of radiation, when all processes cease in an endless empty darkness. What becomes of the quantum immortal then? Is their consciousness the last flicker of organized thought in a universe that has otherwise gone silent? A solitary point of awareness adrift in an infinite frozen void for an eternity that has lost all meaning. The thought is so vast, so desolate, it borders on the incomprehensible. Of course, we must pull back from this precipice of speculation. It is crucial to remember that this is not a proven scientific fact. It is a philosophical consequence of one particular interpretation of quantum mechanics, and the many worlds interpretation is far from universally accepted. Many physicists find it unscientific precisely because it is untestable. We can never peek into these other universes to verify their existence. They are by their very nature causally disconnected from our own. It violates the principle of Occam's razor, which suggests the simplest explanation is usually the best. Why postulate an infinite number of unseeable universes when an explanation contained within our own might suffice? Alternative interpretations of quantum mechanics exist. Objective collapse theories propose that wave function collapse is a real physical process independent of any observer. Bohmian mechanics suggests that particles do have definite positions guided by a hidden pilot wave. These ideas, while also strange, do not lead to the same startling conclusions about immortality. Quantum immortality remains a fringe idea, a ghost in the machine of physics, a piece of speculative philosophy born from the bizarre rules of the subatomic world. It cannot be proven, it cannot be disproven. It exists in a superposition of being both profound truth and elaborate fiction, and perhaps that is its true value. It forces us to confront the sheer, unadulterated strangeness of our existence. It reminds us that the reality we perceive, this solid, stable, predictable world, is a grand illusion built upon a foundation of shimmering probability and uncertainty. It challenges our most fundamental assumptions about life, death, and the self. It whispers that the cosmos is larger, more complex, and infinitely more mysterious than our minds can ever fully grasp. Whether you die once definitively, or an infinite number of times in parallel worlds, the mystery remains the same. What is this consciousness that experiences the universe? Where does it come from and where does it go? The quantum gun thought experiment doesn't give us an answer. It simply takes our deepest existential questions and reflects them back at us through the strange prism of physics. It leaves us here in this one branch of reality we can be certain of to marvel at the fact that we are here at all, alive, aware, and capable of contemplating the infinite.